Hi. In this session we will see how to find the adjoint of matrix with the order or size 2 by 2. That is, I will just consider a matrix, say A equal to 2, minus 3, 4 and 1. So the order of this matrix or the size of this matrix is said to be 2 by 2 because we have 2 rows and 2 columns, right? So in matrices, the main concept is to find out the adjoint of a matrix because it is needed for finding the inverse of a matrix. So let us start with the adjoint of matrix and how to find the adjoint of this 2 by 2 matrix. So generally, how we define the adjoint of this matrix A as the transpose of a cofactor matrix. Okay, so what do you mean by transpose? So transpose is nothing but writing rows into columns. Okay, this transpose, what I am denoting T is nothing but we are just writing the rows into columns or columns into rows. Okay, so here how to find out this cofactor of matrix and what do you mean by these cofactors? Okay, so cofactors are nothing but the signed minors. What do you mean by signed minors? See, that is, I denote C11, that is cofactor of the element which is present in the first row, first column as minus 1 whole power m plus n of m11. Or I will just denote this row and the column as ij. So this becomes ij. And here instead of mn also I am just denoting the letters I and j, where this I denotes the rows and the j denotes the columns. Okay, so this is what the general basic about finding the cofactor of this particular elements, and each element we need to find out the cofactors, and when we put up in its corresponding position, then we can say there is a cofactor matrix. Okay, so now we will come to this example. So here, how to find the adjoint of this matrix A, that is 2, minus 3, 4 and 1. So we have to find out the cofactor. So first we will find out the cofactor of A. So since we have 2 by 2 or 2 rows and 2 columns, here this element is, let us say A11, this is A12, that is first row second column, and this element is A21, second row first column, and this is second row second column. Okay, now if you see, if you consider this A11, here this I takes value 1 and the j takes value 1. So what happens? This C11 will become minus 1 whole power 1 plus 1. So M11. So what happens? This becomes 2. So minus 1 whole square will become plus, and this becomes M11. So that means that we are giving the sign of the element which is which present in the first row and first column as plus. Similarly, when you consider the second element in the first row, that is denoted by A12, here this 1 plus 2 is 3. So what happens? This minus 1 whole power 1 plus 2 of M12. So here this is cube, so we will get minus. Am I right? So here for this element I am just denoting minus. Similarly, for the next one we will get minus because the element is denoted as A21. So 2 plus 1 is 3, which is minus 1 whole power 3. Again it becomes minus. So I am denoting the minus 8. Similarly here for this element A22, that is 2 plus 2 is an even number, that is minus 1 whole power 4. Then it becomes plus. So colloquially speaking, you just give the signs alternatively, plus, minus, plus, like this. Suppose if it is a 3 by 3 matrix, then we will denote plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so no need to concentrate much on this particular thing. This is just a basic, and you can colloquially give these symbols like this. Now we have signed, okay, and we need to find out minors. How to find out the minors? See, for finding the minor of this 2, you just hide the row and the column in which this 2 is lying. So this 2 is lying in the first row and first column. So when you hide these 2, what is the remaining number? That is 1. So that is going to be the minor of this element 2. And for minus 3, to find the minor of this minus 3, this is positioned in the first row and the second column. You just hide this first row and the second column, and the remaining would be 4. So this 4 would be the minor of minus 3. And similarly for 4, to find the minor of this 4, it is presenting in the second row and the first column. When you hide these 2, you will get minus 3. So you put minus 3 here. And similarly for 1, it is presenting in the second row and the second column. You just hide these 2. So what would be remaining? 2 would be remaining. Okay, I am just rewriting this. So plus 1 you can simply write as 1, and minus 4. Here minus of minus 3, then becomes plus 3, and what we have is plus 2. So this is what cofactor of A. I am just representing this with the notation AC, A suffix C. And now our aim is to find the adjoint of this A. So what is this adjoint of A? Adjoint of A is nothing but the transpose of the cofactor of A. So here 1 minus 4, 3, 2. This is what the cofactor matrix what you have found, and we have to find the transpose of this. So what do you mean by transpose? Transpose of nothing but writing the rows into columns or columns into rows. I am just writing the first row as first column, that is 1 minus 4, and the second row 3, 2 as second column, right? So now we have got this adjoint of A. Hope you have understood how to find out the adjoint of a square matrix, that is a 2 by 2 matrix. Thank you.